Hi, everyone. Very happy to be here and back in my alma mater. So for those of you who don't follow me on social media, butterflies have kind of become a sort of symbolism that has gradually become a core part of my identity. So I decided to make it the core of today's presentation as well. So just to start, the butterfly effect, I mean, you're probably all familiar with it to some extent, but it's an actual theory. It's an actual phenomenon that's been, that goes beyond Hollywood movies. And essentially, it suggests that a small initial change, like the flutter of a butterfly's wings, in a complex system can result in significantly different and unpredictable outcomes on the broader landscape. And so the canonical example is the butterfly causing a hurricane. And I've kind of really been thinking about this as a good metaphor for AI's impacts. But just to give a little bit more context of where I'm coming from, for the last 5 years specifically, I've been working on AI and sustainability. So how to ensure that AI is sustainable. A lot of this work has been either kind of the positive impacts of AI or the negative consequences of AI, but really centered around climate change and the environment. And then, I guess, probably a year or so ago, I had a bit of an epiphany, and I realized that focusing only on sustainability, environmental sustainability, doesn't tell the whole story. And so I went back into the literature around sustainable development and started reading about how this term came to be. And actually in the 1980s, there were several definitions of sustainable development that were proposed. And the one that we most adopted, I think, and kind of agreed upon nowadays is the one that came out of the United Nations, which is sustainable development is development that meets the needs of the current generation without sacrificing the needs of future generations, and is really focused about environmental resources, natural resources, etc. But at the same time, in the 1980s, there were competing alternative definitions of sustainability, and then one of them really stuck with me that has 3 components. And so the components are environmental sustainability, social equity, and economic viability. And so the idea is, if you just focus on environmental sustainability, it's not sustainable. If you just focus on economic sustainability, it's not fully sustainable. You have to have all 3 for something to be really sustainable. And I was thinking about this and thought that actually for these last years, I've been only looking at a piece of the puzzle. And so I think that we need to broaden our scope as researchers, as members of the public, to focus on AI's impacts on, sure, the environment, but also society and the economy. And so this is kind of going to be the core of my talk today. But first, someone told me recently, like, oh, you just assume everyone knows what AI is. You should take some time to make sure we're all on the same page, because especially nowadays, with all that we hear in the media, in conversations, I think that I take it for a given that everyone agrees upon how we define AI, and that's increasingly not the case. That's a separate debate to be had. But anyways, the way that I define AI personally, and I think a lot of people do as well, is technology that enables machines to simulate, so mimic, intelligent processes like learning, comprehension, problem solving, decision making, etc. So it's really a matter of machines that have a way to mimic intelligence and that don't necessarily have intelligence. This is a point of debate. And actually, in 30 seconds, AI is not something that came out a couple of years ago with ChatGPT. It actually goes back to the 1950s. That's when the actual field was founded. That's when the term AI was coined and invented. And there were actually some competing terms that had nothing to do with intelligence that were a lot more down to earth, but artificial intelligence won. And since the 1950s, we've had a bit of a winding road. And I think it's really important to think about this, because we tend to focus on this current state of incredible hype and incredible promise, but this is not the first time this has happened. So since the 1950s, the first 20 years were a lot like what we're living now. And then in 1974, we had our first AI winter, when we realized that 20 years of overselling and under-delivering and using a lot of money in the process was actually a little bit misguided. And so we had 6 years of kind of disillusionment and less research and less funding and less everything. Then there was a second summer, as we call it, of AI in the 80s, of rule-based systems. So really lists and lists and lists of rules. And they did work for a time. There were some really, I guess, conceptually interesting ones that would diagnose medical conditions, that could actually, do some some predictions, but they were all based on handwritten rules, and then it hit a wall in the end of the 80s, beginning of the 90s, when we realized you can't possibly write rules for everything. Then we had the current wave of promise that started in the 1990s around machine learning, which is really has been going on since around 1993. And then deep learning, specifically since 2011-ish, and since 2021, generative AI. And I think that it's good to see this big picture, because we realize that, you know, maybe this current wave will also turn into a winter, and there's a lot of overselling currently, so just keep that in mind. Machine learning, yes, I use the term. It was initially inspired by the human brain, so the idea that we have neurons that can create connections, that can reinforce connections, and you know, the more we see patterns, the more these connections get reinforced, et cetera, et cetera. So initially, these neural networks were really inspired by the human brain, and they stack these layers of neurons to produce insights, essentially. And deep learning it doesn't mean that the learning itself is deep, it means that the networks are deep. They have a lot of layers. So yeah, so this was the little intro, just to make sure that we're all on the same page, and none of this is magic. And what's interesting nowadays is that, you know, conceptually speaking, the technology has evolved. We don't have rule-based systems anymore. Now we have machine learning systems, but we also have a lot more AI systems that we interact with every day. So web search, wholly AI, navigation, right? Medicine, a lot of medicine is now, to some extent, driven by AI. Education, for better or for worse. The justice system, maybe not in France, but for example in North America, uses a lot of AI. Companionship, nowadays more and more, especially young children, young adults are using AI as really a companion and a friend, and et cetera. So it's really becoming these ingrained systems, and we become more and more reliant upon them. And in terms of the butterfly effect, going back to that, is that because these systems are so interconnected, and yet atomically they're pretty small, like each individual system is a relatively isolated one, but because they're so interconnected, I think that even, you know, small systems like navigation systems, because they're used by billions of people around the world, can have these ripple effects in ways that were not necessarily intended and are really hard to measure. So let's start with where I'm most comfortable, where I started, the environmental impacts. AI, this is actually, so just a little anecdote. After my PhD, I spent a couple of years working in industry, just really in applied, very kind of down-to-earth AI research, and I had what I call a quarter-life crisis when I realized that the climate change was something that I really cared about, and I decided to find a way to leverage AI in order to fight the climate crisis, and thankfully there were several people around this time in 2008 who were 2018, sorry, thinking about this, and so I met a community of people, and we started kind of looking into the different ways in which AI can help fight climate change, so climate positive applications. So there's actually some really, really interesting ones out there that are both, some of them are still in research phases, other ones are actually out in the world and doing really cool stuff. So for example, discovering new materials and molecules. AI has this really great generative potential in order to come up with new combinations of molecules and atoms that can help discover new materials. So for example, DeepMind does this a lot, creating new combinations of batteries, atoms for batteries, because we know that the lithium-ion batteries that we use are imperfect because they lose a charge, because, you know, over time, actually they're quite costly to make. And so, for example, creating new types of batteries that will last longer and are less environmentally negative can be a really impactful way of using AI, so really at the molecular level. AI also helps us measure biodiversity. My favorite example of this is a startup called Rainforest Connection that uses audio monitoring of the rainforest using AI in order to detect anomalies, essentially, and detect chainsaws, detect people who are in places they shouldn't be chopping down trees, because they're able to use AI to analyze the sounds of the forest. We can also analyze images of animals in order to track not only populations, we can count how many there are, but we can actually even recognize individual members of populations and how often they come back and whether they have children, et cetera, et cetera. So it's really a really interesting application, and a lot of biodiversity ecologists use this. And also at a macro level, maybe you know that like satellites are used for example, GPS navigation, but satellites can also be used for detecting leaks, for example, of gases like methane that are actually very, very harmful for the climate, and of course they're invisible, but using heat patterns we can detect them even from space. We can also even monitor coral reefs from space without having to go and see, like, for example, how temperatures and weather patterns have impacted corals in different places. So there really is a lot of good out there, and this is kind of where I started my journey. And then I had a bit of a reckoning because increasingly people started kind of talking about the cost of AI. And so essentially with this group of people, after we wrote this big paper, we created this organization called Climate Change AI, and we still, it's actually growing and growing. We have hundreds of members all over the world, and we do research, and we try to understand how AI can be a positive force, and also how it can impact the planet. And so in terms of the cost of the planet, what do we mean? Well, for example, every time when we train an AI model, essentially machine learning models need a lot of data in order to learn. And increasingly, this takes millions and millions of hours of compute, of essentially running servers, running computers. And this uses a lot of energy. And that energy has to be generated in some way, right? Here in France, you're pretty lucky because you have nuclear, but in a lot of places that's not the case. And so this is where the CO2 emissions come from. They also come from the manufacturing of the equipment. They come from essentially the whole life cycle of AI models does contribute emissions, and these are growing. So sometimes up to 500 tons of CO2 emissions for training a model, for example, like GPT-3. And so just to give you an idea, a ton of CO2 is more or less a transatlantic flight. And so this is really adding up because we have more and more of these models. They're getting bigger and bigger. There's also the deployment. And so essentially, once a model has been trained, you want people to use it. The idea is that now you have this model that can generate text, that can generate images, that can reply to questions, etc. And so now when you deploy it, that energy also adds up. And so last year I did a study about how different tasks, different ways of using AI have different energy demands and how these translate into carbon emissions as well. And for example, we found that image generation was by far the most energy intensive task because it's, you have to generate a lot of pixels. Usually the images are quite high quality. And so we did this study called power hungry processing to understand a little bit better, once you've trained the model, what happens to it. And to get back to how do we measure this, there's a tool called Code Carbon that I have contributed to and that continues to thrive that actually estimates, actually it measures energy and it estimates carbon dioxide emissions based on how the energy is generated. And so this has become kind of a really important tool in getting actual numbers because despite my best intentions, we have absolutely no numbers about ChatGPT. Until today, but I'm still kind of skeptical about the numbers that came out today or yesterday about ChatGPT, but essentially we can't access these models that we use every day. We actually don't have any idea how much energy they're using or where that energy is coming from, and so tools like Code Carbon, for example, can help developers transmit this information to measure it and to present it to the world. And so essentially it measures the energy and it gives you equivalence. So essentially, in terms of environmental impacts, we're barely scratching the surface. There's so many unknowns. It's very frustrating, actually, because most of the time people ask me questions like, oh, how about my ChatGPT query? How about my questions to Alexa? How about my Google searches? And at the end of the day, we really, really don't know. But we need to assess both positive and negative, because often what people say is, oh, well, AI is going to stop climate change, as if that's a thing, and so no matter the cost, it's worth it. Whereas other people say, well, the cost is so huge that it's never going to make up for the positive impact. And so I think that we should think about both sides of the puzzle, but we do need more answers. Now in terms of societal impacts, this is really interesting because it kind of goes a little bit, it takes a step back to look at how we use AI technologies and how that's impacting our societies. And so, for example, the general consensus is that using AI saves us time, and that using AI tools at work and at home was actually going to free up more time for us. And so, for example, there was a study by Google of Google Maps, and they found that Google Maps users save around 2% of emissions and 6% of travel time. And so essentially, the claim being, if you use Google Maps, you'll save more time, you'll have more free time. But how does that time get spent? What do we do with this newfound time, which is actually, time is, you can't create new time, you can just, there's 24 hours in a day. And how do we spend that time that we gain? And so there was another study more recently that found that from automation, things like robots, things like, AI at home and at work, they do have different impacts, so free time versus higher productivity, but in the end they actually lead to more resource consumption and more pollution because people are traveling more, shopping more. So essentially this free time that was created is used in ways that's actually detrimental to the environment. And so it's interesting because this concept of free time is actually very, very nebulous, and it really depends on how you use it. There's also the fact that our physical world is changing, and this is something that I find that we don't think a lot about, but AI systems have actually replaced objects in our lives. So who even buys dictionaries anymore? Who's ever, I was telling my kids recently, I was like, we used to use maps to drive places. And then like they didn't even believe the fact that maps were a thing not so long ago. Now nobody has maps anymore. Recipe books, actually less and less people are buying recipe books because people are using AI for it. And so actually our physical world is changing. It's dematerializing because of AI and technologies. And so nowadays we use navigation apps. For example, people apparently, this blows my mind, use ChatGPT in order to come up with recipes based on what they have in their fridge instead of opening a recipe book. But essentially, so this physical world that we interact with is changing, is becoming digital. But what is the cost? What is the cost on both in the environment? Because essentially, we only see the devices with which we interact. We don't see the data centers. We don't see the transmission networks. We don't see the undersea cables and the satellites, et cetera. And we also are kind of losing some cognitive capacities, our ability to come up with recipes spontaneously, our ability to navigate, right? Because we're so focused on using Google Maps. Like, I used to study here, and I still looked at Google Maps to get here from the subway, even though, you know, I probably know, and I do, in fact, know, but can I go back somehow? I don't know how to use Mac. Oh, there you go. Because it's become almost a reflex, right? You're going somewhere, you use Google Maps. So it's interesting to think about how this dematerialization is actually impacting both our physical space, but also our mental space. And also, I think that AI innovations are increasingly useful to us. Like, we see them as a very useful technology, but we're also buying more and more things in order to use this technology, which is actually pretty counterintuitive. So, for example, we have phones that we want to upgrade because each time a new tool or a new generation of AI tools comes out, we want the latest and greatest in order to be running these tools. So for example, I think last year Apple Intelligence came out and everyone was super excited, and then if you read the fine print, it was like, well, you need iPhone, whatever, 16 and over, right? That means when you have older iPhones, you can't use the new AI capabilities. And of course, this creates an e-waste problem. But once again, this is not something that we see. So essentially, it's predicted that AI, like specifically gadgets that run AI, can result in 2.5 million tons of electronic waste by 2030. And we're terrible at dealing with electronic waste because it's very expensive. You have to take apart the different components. And so essentially, we're generating whole new, it's like the fastest growing waste stream, more so than organic waste, more so than, you know, clothes or anything. It's electronic waste, and this is really adding up. And nowadays people want, you know, smart microwaves and smart fridges and smart speakers, et cetera, et cetera. And so this is all creating a whole new wave of gadgets that we end up buying and then throwing out. And so with actually one of the previous chairholders, Kate Crawford and Emma Strubel, we wrote this really interesting article that I'm going to go present at the Fairness and Ethics Conference in Greece in a couple of weeks, where we talked about this. We talked about the fact that there's all these rebound effects, there's all these unintended consequences to AI, and we tried to actually categorize them. And so things like substitutions, things like space rebound and scale rebound. And we actually, when we were looking at the data, when we were writing this paper, we found some really interesting trends. Like, we started out with just kind of thinking about it and discussing it, and then we started looking and digging, and we found that, for example, in terms of space rebound effects, mobile phones are shrinking. I mean, if you compare it to like the first generations, like they're getting smaller and smaller and more powerful. But in a very inversely proportional way, data center energy use is growing. And it's really interesting when you look at the numbers, it's actually quite correlated, because we do less and less compute on like our devices that we interact with, and we do more and more compute in the cloud and data centers. So for example, this was a recent report about the United States that projects that in the next, what year are we, 3 years, data centers can use from 6 to 12% of all of the energy in the United States, which is massive, right? And so, but this is something that we don't really see because we have these tiny phones that are so powerful. But they're powerful, of course, they have on-device processors, but they're also connected to data centers that are bigger and bigger and allow us to do more and more. So there's really this kind of inverse proportionality in terms of space. There's also induction effects. So actually, once again, something that we don't think about very often, but AI is hugely used in targeted advertising. And it's actually one of the most successful applications of AI and generates billions of dollars of revenue for the companies that use it. And this is actually how companies like Alphabet and Microsoft make their money, because we are the cookies and the ads that we get are more and more tailored to us. And this allows the models to get better and better, and conversely for them to sell advertising to businesses and sell us stuff that we don't really need, right? And I know that sometimes people are like, oh yeah, my phone is listening to me, and there's a mic that's picking up my conversations. But no, it's just that our online behaviors, our online traces are becoming so complete. We're putting out more and more information out there, and they're getting better and better at using that information that our ads are getting almost, creepily good, because it's almost like they know what's going on in our heads, but it's actually AI. And it's something really interesting because a lot of these impacts are hard to measure. So I talked about Code Carbon as a tool that I helped create because we were so frustrated by the lack of information about the environmental impacts of AI. But how about societal impacts? How about social impacts? How do we measure these kinds of things? Because there's no piece of code that you can run that will actually quantify induction, or the way that our brain changes, or the way that we become dependent on Google Maps to navigate the world. How do we actually measure this? So it's interesting because there's a lot of things that are so there are different layers of impacts that we can think about and that we can try to at least put down on paper, even if we don't have ways of measuring it. So for example, a lot of AI systems, and I've contributed to a lot of these, are developed to have positive social impact. So for example, automatic farming. So essentially developing robots that can pick crops, it can save time, they can even detect pests, they can detect plant sickness. This agriculture, AI in agriculture is a huge, huge field of study and research. And so they can do precision agriculture. So robotic arms can actually do their own picking of lettuce and strawberries, et cetera, and this saves money. And usually the criteria that's used is money, right? Money or hours spent or et cetera. But what happens to the people who were doing this work before and who now don't have a job, right? And often these are not the same people who are paying for the robots. There are people who are sometimes undocumented, mostly dependent on this kind of work. And so essentially we're starting to see, for example, in California, among the many geopolitical issues going on there right now, the fact that robots are replacing communities that used to do this work by hand and that would actually kind of migrate from farm to farm. Nowadays it's a lot robotically assisted, but we have no way to quantify this because often these people are undocumented, or at the end of the day, farmers are not measuring how many migrant workers they didn't hire, they're just measuring how much money they saved. Another interesting, so how do we measure the good of AI? Another interesting example that I particularly find fascinating is solar geoengineering. So this is one of those kind of potential solutions to climate change that involves essentially modifying the reflexivity of the Earth. So essentially because of melting ice caps, because of the ozone layer, although it's a little bit better now, but we're losing the Earth's ability to reflect heat back into the atmosphere, and so back into space, and so this is why we're having global warming. And so one of the proposals is, well, what if we put aerosol particles, reflective particles, into the atmosphere so that they will do the job that is no longer being done. And so this is an actual field of study. There's a lot of models that exist, and AI is actively being used in this field of solar geoengineering as a way of modeling, if we put a bunch of phosphorus in the atmosphere in California, how that cloud is going to move through the Earth and how it's going to reflect sunlight. And so one of the big applications in AI, but actually what's interesting is that how do you optimize results? I was reading a couple of articles on solar geoengineering. So for example, often they'll be like, well, in the US, we have lower temperatures, we have less drought in California, we have more rain, et cetera, et cetera. But then if you look at other regions like Western Africa, they're actually worse off because the models get optimized for where the models are coming from. And so it's really interesting because there's more and more work around like bias in things like this, because it's so hard to optimize for everyone. It's actually impossible. You can't kind of make a model that will have equally good impact everywhere. So at a certain point, decisions must be made. And so how do we make these decisions, especially when AI is being used? And so one of my pet peeve questions that always comes up is, can we compare the environmental impacts of humans, of people, and AI? And so often, probably not in places like this, but in places that are very techno-positive, the overwhelming majority of people think that, AI is actually a net benefit because it uses less resources than human beings, and we can automate all these things and save all this time. So actually, AI is better for the planet, is a dominant theory. And so there was this study that came out actually last year that compares humans, human writers, and human artists to AI models. And essentially, they took the average carbon footprint of human beings in India and the United States, and they compared it to the carbon footprint of hypothetically ChatGPT, but also Bloom, which is an open source model that I worked on. And essentially the conclusion was AI writing produces 130 to 1,500 times less CO2 per page than a human author. And a similar conclusion was made for image generation and human graphic designers. And so essentially, you know, the tacit conclusion was, well, if we replaced all human authors by AI, you know, we'd be better off. The planet would be better off. But if you read somewhere hidden in a footnote, it says, emissions analyses do not account for social impacts such as professional displacement, legality, and rebound effects. And so essentially, it's like they do all this analysis, and this was heavily reshared on social media by very prominent members of the AI community. I will not name any names, but they spoke at Viva Tech today. That said, okay, well, actually, you know, we should just do away with all these pesky humans and replace them with AI. But at the end of the day, this is not even scratching the surface of the impacts that we should be looking at. It's only taking a very, very flawed metric, and also not taking into account that these AI systems that they're, you know, measuring the impact of were trained on books written by human authors, by images created by human designers, and you can't just discount that and pretend that this all exists in a vacuum. And so my response to can we compare the environmental impacts of people in AI is no, we cannot. We should stop trying, and essentially you can't compare humans and machines. And so essentially for me the bottom line is that we need more research and analysis to measure societal impacts, that we have certain data points from, you know, Google on one hand and this study on the other, but it's really not enough to have a better idea of how AI is impacting society. And this work needs to be multidisciplinary and transversal, because like when I was talking to my friends who do kind of life cycle assessment, when I showed them that study about humans and AI, they're like, you can't do that. That's not how environmental impact assessment works. You can't just like cherry pick numbers and compare them and make conclusions. You need to think about the life cycle. You need to think about, you know, the holistic, like, you know, what is a human being? A human being is more than just our job. You can't just take a annual carbon footprint and divide it by the time it takes me to write a page and then assume that that tracks. That does not track. And same thing with AI. You have to take into account the training. You have to take into account where the data was coming from, et cetera, et cetera. And so essentially we need more multidisciplinary work and less kind of polarized research in order to understand this better, because I think that my favorite allegory of the blind men and the elephant, I think there's a lot of that going on. Everyone's kind of like touching a different part of the elephant, but we can't agree upon what it is that we're, that we're facing. And finally, economic impacts. This is really interesting, and I think this is where I'm most out of my depth, but I've been working with economists and trying to understand a little bit more economic impacts of AI, because we hear a lot about job displacement and these big, you know, big changes to our economy, but like, how does this actually get calculated? And there's this really recurring topic that comes up. It's Jevons paradox, and it's being kind of picked up in AI. And essentially, it's an economic concept that says when technological progress increases the efficiency with which a resource is used. So, for example, coal. We were getting better at using coal, so we could, for example, generate more energy from the same amount of coal. But since that is getting cheaper and cheaper, actually, this increases demand and essentially increases usage. So at the end, we're using more coal because we can do more things. And so essentially, an example of this is, for example, cars. Now, cars are super fuel efficient, and yet people are driving more and more, which is counterintuitive, because you would think that if before, for, you know, a liter of fuel, you could go, I don't know, whatever, 50 kilometers. Now you could go 100 kilometers, so you should be using half a liter of fuel, not a whole liter of fuel. But no, people will go further. People will go further for vacation. People will travel further because they're able to, because for the same amount of money, they can go further. And so essentially there's this theory, once again, by certain tech CEOs that we're seeing a Jevons paradox in AI. So AI is getting more efficient. We're going to see its use skyrocketing, turning it into a commodity that we can't get enough of. But for me, this is a kind of a very limited understanding of Jevons paradox, because essentially the training costs are still going up. So yes, it might be that hardware is getting more efficient, and I think, you know, that is the case. GPUs, so the computers that are used for training AI, are getting more and more powerful, more efficient. We can train bigger models, but still the cost is going up. So this is a plot that estimates the monetary value of training an AI model, how much it cost back in 2010 or earlier, and now 2025. And we've gone from a couple of dollars to a couple of millions of dollars, so tens of millions of dollars in the space of 10 to 15 years. So essentially, yes, we might be getting more efficient at AI, but we're still doing more of it. And so the cost of AI is still going up. And so another paper that I'm also presenting at FACT in a couple of weeks was written by Gaël Verrocco, who's a researcher in RIA, Meredith Whitaker, who's actually also based in Paris now. She's the CEO the president of Signal, and myself, and we were talking about this idea of bigger is better. Because there's this obsession in AI, it's actually very interesting, that large-scale production is supposed to have less cost of units. It's essentially taking ideas from like IKEA furniture, right? IKEA furniture is cheaper because we make more of it, and now we can buy a bed for $100 and not $500. And essentially, applying this to AI, people are like, well, we have bigger models, we can train bigger and bigger models, so the cost should be going down. But we're actually seeing the cost and the impacts going up because, you know, AI models are not IKEA furniture, and because we're seeing this race towards these bigger and bigger models by companies around the world. And so, for example, in our paper, we talk about, for example, how less and less people can afford to train these models because for the same amount of money, you can get more, for example, you can get more storage, but it still takes you more compute. And essentially, for example, the actual supercomputers that are used for training AI are mostly owned by private companies. And so it means that we're using, you know, money for funding academic research that goes to big tech companies because we need access to the compute. And of course, there are some public computers. There's one here near Paris, it's called Jean Zay, but compared to the big clusters that technology companies have, it's still very, very limited. So people are getting more and more dependent on these supercomputers and the technology companies that control them. And actually, this also creates concentration of power, which is really interesting. There's a study that was done a couple of years ago that looked at, you know, where the top AI papers are coming from, where the top models are coming from, and essentially, you can really see that it's concentrated in West Coast of the US, so California, some East Coast as well, Europe as well, but almost all of the global South is not represented by these models because it's hard, it's expensive. It's expensive to train AI models. It's expensive to deploy AI models. Often there are no supercomputers in the global South. They're not local. They're in the global North. And so essentially this creates a barrier to entry in the field. When I started in AI, I mean, here as well, but especially in my PhD, you could still train an AI model on your laptop. And that meant that a PhD student or, you know, a postdoc could train a model, submit it to a conference, attend the conference, you know, get ideas, get feedback, improve their model, and keep building and keep improving. But nowadays, as the barrier to entry is rising, you need more and more money in order to compete. That is less and less the case. It's harder and harder for grad students, for academics, to actually break into the field. And so what we're seeing as well is more and more corporate affiliations. There's a really interesting paper called The Elephant in the Room, and it looks at like industry influence on academic research in AI. And essentially more and more people have to have industry affiliations with companies like Microsoft, IBM, and Meta to have, I mean, majoritarily to have access to their supercomputers, because you can't train a model on your laptop anymore. You need this dependence, you need this sponsorship essentially from big tech companies. But of course, when you say sponsorship, when you say money, there's this tacit influence on what you work on, right? Because companies that will give you money, that will fund your research, will also have a certain agenda, certain things that they want you to work on, or certain things that they don't want you to work on. And so this really creates a weird dynamic in terms of, you know, researchers that rely on companies and companies that influence researchers, and it's getting harder and harder to do independent academic research in AI. And essentially, there's this theory, let's say, that certain AI models can actually impact our whole economy. And there's this really interesting paper, interesting but confusing paper, that's called GPTs or GPTs from OpenAI. And essentially it looks at labor markets of large language models. And so ChatGPT is an acronym, so Generative Pre-trained Transformer. But there's also this economic concept of general purpose technology. And so what they're arguing is that ChatGPT type models are general purpose technologies that have the potential to change whole labor markets and actually replace whole types of jobs. And so they're saying that their model, their AI model, by the way, labeled 86 occupations as fully exposed to be replaced by AI. Things like climate change policy analysts, apparently, but also journalists, legal secretaries, accountants, and auditors. Essentially, according to this, they're saying, well, all of these professions will disappear because AI can just replace them. But who will be responsible for this displacement, right? What happens when a model created by a tech company replaces all accountants all over the world, right? What happens to who pays the money for these people who don't have a job anymore? What happens to new graduates who have degrees who wanted to practice that job? And so how do we think about this labor disruption that companies themselves are saying? So OpenAI is saying the tool that we're making, these tools that we're constantly making better and better, these AI models are going to wipe out whole professions. And yet we don't talk about job displacement responsibility. We don't talk about accountability of these products that they're making. And so essentially, I think that what we need in AI is not more energy, it's not more electricity, it's less concentration of power. And actually, as a researcher, I find it very disheartening, very sad that we're having these, essentially these very conflicting dialogues, right? On one hand, AI is going to save the world, and on the other hand, it's going to, whatever, use all of the energy in the United States. Is it going to create jobs? Is it going to displace jobs? Is it going to create time? Is it going to save us time? It's really a very binary discussion, and it's very frustrating. And I think that we can also still steer AI in a different direction by changing the way we do things, essentially by challenging the status quo and thinking about different ways of practicing AI model training, by creating mechanisms to make things a little bit more holistic. And so as a conclusion, and kind of to make the tie with my chair and what I'm going to be working on in the next year, I want to study AI's impacts on society, economy, and the environment together, because I realize that any single one of these pillars of sustainable development is not enough. And so essentially, I blame myself for only focusing on environment, but now more and more I've been speaking to economists and ecologists and socio-technical experts, and I realize that a lot of the concepts that we talk about, things like impact assessment, things like measurements, things like job displacement, it's funny, so it turns out that AI researchers and practitioners have this really terrible reputation in other fields that we constantly pretend that we've rediscovered something that people have been talking about for decades or hundreds of years sometimes. And philosophers say this. The philosophers are like, yeah, you guys write papers about self-driving cars and you ignore Plato and Aristotle. And economists say this, saying that, okay, you talk about labor impacts and job displacement, but you ignore all these theories and all these models that do exist. And ecologists are like, you compare human beings and machines and you don't even bother to use the right methodology. And so this is why I think it's really important to think about things holistically, and that anything that impacts the society is going to impact the environment. Anything that impacts the economy is going to impact society, and they're all actually pieces of the same puzzle. And I think that really, as Tanya mentioned, the core of this is frameworks and tools, because unless we have numbers, unless we have actual tangible metrics, it's all going to be he said, she said, or this is not a problem. And I think that often, and actually we are working on a paper about this, often a lot of the decisions that we make are based on kind of estimates or these kind of urban legends of, oh, this is a ChatGPT query is this much energy, or bottle of water, or we have all these myths, but it's not actually anchored in real facts. And what we need is more measurements. What we need is actual information about what is the impact of the tools that we're using and how do we quantify this. So for example, a couple of years ago, I was invited to the Bill Gates Foundation in Seattle, and they were looking at AI tools for good. And then essentially they were like, oh, well, we can create chatbots for farmers to give them advice on when to plant their crops. And they were looking specifically at Africa, saying we're going to help farmers in Kenya use some form of large language model in order to decide whether they should plant a crop now or in 3 days from now. And then I asked, well, what happens if the advice is wrong? What happens if people lose their crops because AI told them to plant early or too late, right? And this is not something that gets factored in. What gets factored in is the cost, eventually, some form of user testing and how cool it is to interact with a chatbot. But what happens to the actual social impacts? They don't get measured. They're not reflected in the way that these tools are developed. What is reflected is, oh yeah, this this tool can reply to any question. It was trained on all these farmers' manuals, but we don't talk about the actual impacts. And also, a core part of this is interdisciplinary work. So more and more, I'm working with economists and ecologists to understand where they're coming from and how to leverage their knowledge in AI. Because more and more, so typically, for example, when we talk about climate impacts. When we talk about industries, you talk about verticals, so agriculture, transportation. For example, the IPCC has all these categories of industries, and we have numbers for them. So, you know, the cement industry is responsible for this much emissions. The transportation industry, or like airplane travel, is roughly 3% of emissions. And we have these verticals that we're tracking across time to understand how they're evolving. And AI tends to get put into the information and communications technology bucket, which is like cell phones and internet transmission networks and things like that. But if you really think about it, AI is really not a vertical but a horizontal, because it can impact agriculture, it can impact transportation, it can impact cement production, it can impact all these different things. And so if you're tracking AI in any isolation, in any isolated way, you're not factoring in these impacts. And so I think it's really important to look at different domains, look at different contexts, and how AI fits into those existing domains. And I also are more and more convinced that we need to find ways for the AI industry to become more transparent and accountable. And I spent my last couple of years essentially fighting and trying to call them out. And now I realize that, well, maybe this is not the most productive way of collaborating with them. And now I'm trying to make it about incentives. And this is also an economic concept that economists have been working on. So how do we incentivize companies to be more transparent? And for example, actually, this morning I had some good news. It's been about 3 years that I have been trying to get NVIDIA, which is the biggest producer of AI training, like computer chips for training AI. I've been trying to get them to publish what's called like a carbon footprint report. And today they finally released their first one. And then they wrote to me saying, you've been most annoying about this for a couple of years. And so you're the first person that we send it to. And so, you know, I mean, I've stopped kind of antagonizing them, and I started to have calls with them and to discuss and be like, how do we work together, et cetera, et cetera. And so, you know, it's not necessarily something I'm very good at, but it's something I want to develop in order, because I think that this is where this is going to get more and more important, because AI is majoritarily coming from industry, is coming from for-profit companies, but how do we make these for-profit companies accountable and transparent? I think it has a lot to do with incentives and working together and not just yelling at each other. So thank you for your attention, and if you have any questions, I'm here.